Right, today we are going to do differentiation. Right, this is one of the section in calculus. So first we will consider one function y is equal to fx. So any function, we can draw the graph, the linear function, straight line graph, quadratic function, so parabola, but this is the any function y is equal to fx, we can draw. So we will take one point on this curve. That point is px comma y, px comma y. So another point q, if we give small increment in delta x, small increment in x, we are calling that is delta x. So corresponding delta y we will get. Okay. If we are giving small increment delta x, then we will get corresponding value for y, we call that is delta y. So this delta x given by us, but delta y we can get from the graph. So this is delta x, this is delta y. So now x coordinate increased by delta x. So the x coordinate of q, x plus delta x. At the same time, the y coordinate of p, y, now y coordinate of q, y plus delta y. So we can mark the x coordinate is x plus delta x, comma y coordinate y plus delta y. In other way, any function, for example, y is equal to say x cube plus 3x plus 1. So this is x is equal to 1. X is equal to 1. Then y is equal to what? If you substitute 1 cube 1 plus 3 into 1 3 plus 1 plus 3 plus 1 5. So this coordinate is 5. So if we call this is fx, then f1 is equal to y. f1 is equal to y coordinate, that is 5. So we can mark this coordinate 1 comma 5. In other way, 1 comma f of 1. f of 1 is 5. So if we consider this is x, then x coordinate is x, then y coordinate is fx. Y coordinate is fx. So 1 comma 5, we can write it 1 comma f1. At the same time, if we give x coordinate is x, then x comma fx. So in other way, we can call this coordinate x comma f of x. This is the other way. Then what about q? X plus delta x, this is the x coordinate. The y coordinate f of x plus delta x. So in place of x, here x plus delta x. Here in place of f of x, this x, f of x plus delta x. So we can call this delta y. This delta y. This y coordinate is f of x plus delta x. This y coordinate is f of x. So in other way, we can write f of x plus delta x minus f of x. This is the other way. Okay? F of x plus delta x minus f of x. Right. The delta y by delta x, the ratio delta y by delta x is the gradient of chord PQ. Chord PQ. So gradient of PQ, m of PQ. The gradient of PQ is equal to the tan value opposite over adjacent or rise over run. So m of PQ delta y over delta x. Delta y is change in y, delta x increment in x. So this delta y by delta x meaning the gradient of PQ. Now the point Q tends to P. That is the meaning. We are moving this point from Q to P. From Q to P. Then this chord will change like this. So gradient will decrease. So Q tends to P, then delta x tends to 0. Then delta x tends to 0. If the Q move along the curve up to P, then automatically delta x tends to 0. Or other way, if delta x tends to 0, then Q tends to P. Q tends to P. So in this case, the M of PQ, gradient of PQ tends to gradient of tangent at P, gradient of tangent at P. Gradient of tangent at P. Okay. So if the Q move along the curve up to P, then gradient this line move like this, and finally that is the tangent at P. So we can write limit of delta x tends to 0. Limit of delta x tends to 0. That's the meaning Q reached P. Limit of delta x tends to 0. Delta y over delta x is equal to gradient of tangent at P. Gradient of tangent at P. Okay. But definition, there's a definition. Limit of delta x tends to 0, delta y over delta x is equal to dy by dx. This is the definition. So definition, then we can't ask why. This is the definition. So limit of delta y by delta x, we know dy by dx. So we can put in place of this dy by dx. So what is the meaning of dy by dx? So dy by dx is equal to the gradient of tangent, M of tangent at P. Gradient of tangent at P. So if we are giving y is equal to fx is the given function, then we can find dy by dx, that is the another function. So if they are giving y is equal to fx, if you find dy by dx, then you will get another function. So we can call that function is f dash x. So what is the meaning of f dash x? This is the variable function. So that is the meaning gradient at any point x comma y. So if we change x comma y, now this is the gradient, like that, the gradient will change. So that is the variable function. So if we need particular point, say dy by dx at 1 comma 2, dy by dx at 1 comma 2, then you have to substitute in this function. This is only in terms of x, so you have to substitute this coordinate here, then f dash 1. If you need at this point the gradient of the curve, then f dash 1. So f dash x is the one function. If you put x in place of x1, you will get one particular number. That number meaning m gradient at this point. That's the meaning. You have to draw the tangent at this point 1 comma 2. If you draw the tangent, the gradient of the tangent is f dash x at x is equal to 1. Right. So now we have dy by dx. Dy by dx is the gradient at P. Dy by dx gradient at P. So dy by dx you can write like this in another way.